Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. In this video, I'll be going over the Intro Math Handout sheet number 1, or converting a number from decimal notation into engineering notation, and then furthermore into metric prefix. So looking at our sheet here, we have a few things I want to point out to you just getting started. So the first thing here is our numerical value. That's this number right here. We're in decimal notation, and the final thing is the electrical quantity that we are measuring. And there's several electrical quantities we will be measuring. There's a list of them right here, several different ones. And this is on that Intro Math formula sheet that I provided to you. So you can see here that we're going to be measuring several different electrical quantities, such as volts, amps, ohms for resistance, watts, hertz for frequency, henries for inductance, and farads for capacitance. All right, if we look at our next column here, we have our value, but we are converting to engineering notation. Then our final column is where we have our numerical value. We'll have a metric prefix instead of engineering notation, and we'll have our electrical quantity. All right, so let's begin with number 1 here, and we're going to do a few by hand to get started. Now, one of our rules of converting a number into engineering notation is that when you're converting to engineering notation, your exponents must be a multiple of 3. And here are the exponents that we've talked about. These are the 8 metric prefixes that we're going to be using. Kilo, mega, giga, tera, 10 to the 3rd, 10 to the 6th, 10 to the 9th, 10 to the 12th. Then micro, nano, and pico, 10 to the negative 3rd, 10 to the negative 6th, 10 to the negative 9, 10 to the negative 12. And of course, we'll just be inserting the abbreviation letter once we've done that conversion. And that'll become a lot more clearer to you as we go forward here. And I give you several examples. So we look at our first number here, which is 3,500,000 ohms. And the first thing I'm going to do is I'm going to convert him into engineering notation. Now I know right now that I have to convert him because my numerical coefficient has to be between 1 and 999. So I'm going to go 1, 2, 3, 4, 5, 6. So that's going to give me 3.5 times 10 to the 6th. I had to go 2 jumps of 3 because if I would have only went 1 jump of 3, that would have been 3,500 times 10 to the 3rd. But 3,500 is greater than 1,000, so that was still too large. So I had to take another jump of 3 to get my answer of 3.5 times 10 to the 6th. Now my numerical coefficient, which is this part of the number, the part of the number that's to the left of that multiplication sign, his name is the numerical coefficient. Well, now my coefficient is between 1 and 1,000. And I'm jumping in jumps of 3 here. Instead of counting single decimal places, I'm not going 1, 2, 3, 4, 5 like that. I don't want to count single decimal places because by counting single decimal places, you actually can wind up with an exponent that is not a multiple of 3. But if I jump in jumps of 3, 1, 2, 3, 4, 5, 6, that helps me to keep my exponent number a multiple of 3. So my first conversion is from decimal notation to engineering notation. And this same exact number of 3,500,000 ohms is now set and converted into 3.5 times 10 to the 6th. Now my next conversion is even easier, because all I have to do is look at this part of my number right here, 10 to the 6th. And that 10 to the 6th, when I look at this chart, tells me what metric prefix to use. So looking at my chart here, 10 to the 6th is right here, which is mega, and it's the abbreviation of a capital M. So that tells me whenever I make my final step, I just let this 10 to the 6th tell me what letter to put there, because I'm going to keep my numerical value of 3.5, and my metric prefix, I just looked it up. 10 to the 6th is uppercase M, and I was measuring ohms here, so that's my electrical quantity. So my final answer is 3.5 mega ohms. Mega stands for millions. My next one here, I see that it's already greater than 1,000, so that tells me that I have to convert it. So I'm going to go in one jump of 3. All right, that tells me 1.2 times 10 to the 3rd. He's between 1 and 1,000. If I jump again, he'll be less than 1. It'll always be between 1 and 1,000. It'll never be less than 1. It'll never be more than 999. So with one jump of 3, I see that now I have 1.2 times 10 to the 3rd. When I get ready to convert it to metric prefix, I see here that 10 to the 3rd, if I look at my metric prefix sheet, 10 to the 3rd stands for kilo, lowercase k. So now I'm going to keep my numerical value of 1.2, and the times 10 to the 3rd tells me actually that would be kilo, and I was measuring volts. All right, my next one here, I'm going to go 1, 2, 3, 4, 5, 6. I'm not going to jump another jump of 3 because that would be 0.160, which is less than 1. So I go 2 jumps of 3. That shows me that it's going to be 160 times 10 to the 6th. And 10 to the 6th, I look here, is mega, capital M. So it's 160 mega, and I was measuring watts. Now, here is one that is a decimal number, or less than 1, that I need to convert into engineering notation. And whenever I'm going to convert a number that is less than 1 into engineering notation, I'm going to have a negative exponent. And this one is a good example of why jumping in jumps of 3 can be so helpful. All right, so it's 0.00055 amps. And I'm going to do away with the A here just for a minute, just to help me make my point to you. Just by human nature, I want to put my decimal point behind that second 5. But if I did that, my conversion number would be 55 times 10 to the 5th, which is not a multiple of 3, obviously. But if I jump in jumps of 3, it shows me that I have to go 1, 2, 3. Now I'm locked into a second jump of 3 because I want my exponent to be a multiple of 3. So I'm going to go 1, 2, 3 again, and I'm going to fill in a 0. So my number is actually going to be 550 times 10 to the negative 6th. And it's a negative 6 because it was a decimal number. It was a very small number. And it's 550 because I'm locked into jumps of 3, and 550 instead of 55 is what makes my exponent be a multiple of 3. Now when I get ready to take my next step, all I have to do is look at this times 10 to the negative 6. You have to have it memorized for the test, but for right now we'll just revert to the chart. So negative 6 is micro, which is actually the Greek letter U. I'm sorry, the Greek letter mu. But you can just type a U on your computer, that's good enough. So we're going to keep our 550 because that is our numerical value. But we're going to swap out our times 10 to the 6th for our metric prefix, which we just looked up to be micro, and we're measuring amps. All right, my next one, again, I'm dealing with a little number, and I'm going to go in one jump of 3. So it's 150 times 10 to the negative 3rd. which is 150. I look here and it tells me milli. And what was I measuring? Volts. All right, my next one, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't stop there. That would still be less than 1. 10, 11, 12. So it's 9.42 times 10 to the negative 12th. And I look at my chart up there, and it tells me that negative 12 is pico. So this would be 9.42 picofarads. All right, the next one is 2,270 ohms. One jump of 3 puts me at 2.27 ohms. Puts me at 2.27 times 10 to the third ohms, because I had one jump of 3. And 2.27 times 10 to the third tells me kilo. And I was measuring ohms. 42,100 hertz to jump one jump of 3. And the answer is going to be 42.1 times 10 to the third. And 10 to the third is kilo. So it's 42.1 kilo. All right, my next one here, I can jump one jump of 3. So that would be 33 times 10 to the negative third. Because this is a little bitty decimal number, I'm moving my decimal point to the right. If I move my decimal point to the right, I get a negative exponent. But all you got to remember is if it's a little bitty number, you're going to get a negative exponent. And this one is less than 1. So with one jump of 3 would give me 33 times 10 to the negative third. 10 to the negative third tells me that that's a milli, so it's going to be 33 milliamps. Last one by hand. Going to jump 1, 2, 3, 4, 5, 6. So it's going to be 6 times 10 to the negative 6. And negative 6 tells me micro, so it's going to be 6 times 10 to the negative 6. And what was I measuring? Watts. All right, so hopefully you have your calculator handy. This is the Casio FX115 ES Plus. Now this is the first generation, and the second generation is currently for sale, so it looks a little different. But all of the buttons are the same. And this is usually the point in class where I go ahead and have everyone set up their calculators the same, where you're getting the same functions as I am. So let's do that. The first thing we want to do, if your calculator ever gets to where it's giving you an I, sometimes it gets where it gives the letter I for answers, and it's not calculating as you want it to. Well, in that case, I recommend just doing a full factory reset. So when we look at these keys here, these are multifunction keys. Right now, if I press this button, I get 9. I just get what's on the face of the button, the number 9. If I hit shift, I get what's above the key in gold. Whatever button I press after I hit shift, I'm going to get what's above the key, not what's on the key. If I hit alpha here, I will get what's in red above the key if it has that feature. You can see not all of them do. So the first thing we're going to do a factory reset. So I'm going to hit the shift button. I'm going to hit the number 9, and you can see above the number 9 it says clear, CLR, clear. Once I hit that, I want to hit 3 to clear everything. I want to hit equals for yes. And then I want to hit all clear to get me back home. So again, that was shift 9, 3 for all, equals for yes, and then all clear button. All right, now I want to make sure I'm in the proper mode. I don't ever want my calculator to be displaying scientific because we don't really want to use scientific. So I'm going to hit the shift button. I'm going to hit the mode setup button. And I'm going to hit number 1 for math 10 and then number 2. All right, the next thing I'm going to do is I'm going to go shift mode setup, and I'm going to be in normal mode, not scientific mode, normal mode. So I hit the number 8, and then I hit the number 2. All right, next I'm going to hit the shift button. I'm going to hit the mode setup button one more time. And right here, number 6, it says fix. Well, that stands for fixed decimal places. How many decimal places do you want to display? And to be honest with you, I'm going to hit number 6 to go into that function, and I'm going to hit number 9 just to go with the maximum number of decimal points. Now, a lot of times that's going to give you a bunch of zeros behind the decimal place. You just have to disregard some of those zeros and understand what the number is that you're looking at. Another thing, if you ever get a fraction answer, you can always hit the S to D button, which stands for standard to decimal. And if you got a fraction up here, you hit S to D button one time and it'll convert it for you into a decimal number, which is definitely what you need. All right, so let's put in our first one here, which is 77,700,000. 77,700,000 hertz. All right, so I punched the number in my calculator. I hit equals, and it seems like nothing happened, but nothing was supposed to happen yet. You're not in scientific, so it didn't convert it to scientific. We didn't really want it to. All that really matters is you're going to hit this engineering button right here. And when you hit this engineering button, it will convert it for you into engineering. So I hit the engineering button. So 77 times 10 to the 6th. As before, I'm going to keep the 77.7, and I'm going to look at my chart, and times 10 to the 6th is mega, capital letter M, and I'm measuring hertz. All right, my next one is a little bit different because he's already between 1 and 1,000 when I get started. Now, I can still see what he'll look like in engineering, though. So if I go 100 and I hit equals, this is just 100 with all the decimal places because I'm set to 9 decimal places, but it's still just 100. And I hit engineering, it says 100 times 10 to the 0. So make sure you do write that down, even though we're not really converting it. This is still technically the engineering notation for this number. So it's 100 times 10 to the 0. And we look at times 10 to the 0. Well, there is no metric prefix for times 10 to the 0. So we don't have to put a metric prefix. So my final answer is 100 amps. He was already okay the way he was because he was between 1 and 1,000 to start with. And there is no metric prefix to insert. Same thing with the next one. He's already between 1 and 1,000. Still going to punch him in through the calculator. 87. Hit equals. Hit engineering. 87 times 10 to the 0. Telling us there is no metric prefix. So my final answer, I'm going to keep the 87. There's no metric prefix. And I was measuring volts. All right, looking at the next one here. It's a decimal number, so it's going to be a negative exponent. Oh, I was about to do it by hand. Let's do it in our calculator. All right, so it's 0.0018. I hit equals, and I hit engineering, and it converts it for me. 1.8 times 10 to the negative third. And we look at our chart and it tells us that -3 stands for milli. So it's 1.8 milliamps. Our next one actually would be easier to do by hand. I don't even know if we can put that many zeros in our calculator. And then I'm going to put my 9.5 equals, still in decimal, but I'm going to hit engineering, 95 times 10 to the -9. And I look on my chart and it tells me that -9 is nano. 95 nano, and I was measuring farads. Okay, this next section on your sheet here is really just memorization. There's no calculations that you're doing here. So I see here that I have 5.5 kilo ohms, and I want the numerical value and the engineering notation for each one of these numbers. Well, I'm going to keep the 5.5, and the lowercase k tells me times 10 to the third. 5.5 milliamps is going to be 5.5, and the lowercase m tells me times 10 to the -3rd. 6.2 mega ohms. I'm going to keep the 6.2. The uppercase m tells me times 10 to the 6th. 150 kilo ohms. It's going to be 150, and the lowercase k tells me times 10 to the third. Number 20, 99 kilowatts equals 99 times 10 to the third. 10 milliwatts equals 10 times 10 to the -3rd. 750 microfarads. All right, I went ahead and pulled the chart down for reference. Okay, number 22, 750 microfarads. So I'm going to keep the 750. I look at this U right here, and that tells me micro. So I'm going to use the letter U, which tells me that corresponds to times 10 to the -6. 55 milliwatts. I'm sorry, 550 milliwatts. And lowercase m tells me that it is times 10 to the -3rd. 10 megahertz, so it's going to be 10, and mega is the 6th. Number 25, 3.2 nanofarads. Going to keep the 3.2, and the n tells me times 10 to the -9. Okay, numbers 26 through 40 work the same exact way, so I'm not going to go through every one of those. I will remove the cover here so you can see the answer, just to make sure you're doing your work correctly. These are the values you should be getting once you have converted them. And this information is vital to know, because going forward, we're going to have to know how to use these numbers in order to do any of our calculations. So I can't emphasize enough to you how important it is for you to learn this information now, and to memorize your metric prefixes and memorize your electrical quantities of measure. So we see here on number 41 that we want to add two numbers given to us in metric prefix. Now, since the number is given to us in metric prefix, we have to memorize what these numbers stand for in order to be able to punch them into our calculator in engineering notation. Because we have to be able to look at a number that is in metric prefix and know what its engineering notation is. So the first thing I want to emphasize to you when entering in a number that is expressed in metric prefix, we're going to enter that number in to our calculator in engineering notation. We have to hit the proper key sequence. So we see here we have 180k ohms. We're going to go 180. Now I got to do my times 10 to the third for my kilo here, my lowercase k. Now looking at the calculator, it is essential that when you get ready to do times 10 to the third, you hit the middle button on the bottom row, right here. This is your exponent button. Times 10 to the whatever. Well, in this case, we know that it's times 10 to the third. Now I'm going to enter my second number, so I'm going to hit plus. I'm going to put 200. And again, I'm going to hit my exponent button, times 10 to the third again. And that's going to give me an answer of 380,000 in decimal, but we really want engineering, so we hit engineering, and it tells us it's 380 times 10 to the third, which is 380. That's our numerical value, times 10 to the third tells us kilo, and then the electrical quantity of measure, we were dealing with ohms here, ohms. 380 k ohms. Now what you want to make sure that you don't do, looking at the calculator again here, you cannot go 180, and when you get ready to enter kilo times 10 to the third, you cannot go times 10. No, that's not going to work. If you try to do that, it's going to mess up your math. If I was to open parentheses, close parentheses, plus 200 times 10 to the third. Yeah, that's not the right answer at all. The answer you're looking for is 380 k ohms. And this is 11.4 k ohms. So it did not add it correctly. So just make sure that after you enter your numerical value and you get ready to convert the metric prefix over to engineering, that you hit the middle button on the bottom row, which is your exponent button, then followed by the correct metric prefix the correct exponent that corresponds to the metric prefix. So when I look here and I see this K right here, this K tells me that I put a 3. Plus 200, look at this K right here, and that tells me that I'm going to do times 10 to the third. Equals, hit engineering, and it's 380 k ohms. Now on this next one, what I want to show you, something very interesting here. You have 500 plus 500. Well, normally 500 plus 500 would be 1,000. But remember, our number must be between 1 and 999. Between 1 and 1,000. It'll be some number between 1 and 999. So let's actually do the math here. So I've got 500 kilowatts plus 500 kilowatts. So let me punch it into my calculator. Looking at my calculator, I'm going to go 500 times 10 to the third plus 500 times 10 to the third. It equals, and when I hit engineering, it actually shows me that it's going to take that number up to 1 mega, because 1,000 would have been too big. So 1,000 kilowatts would have been too big of a coefficient number. So it actually takes it up to the next metric prefix, which is times 10 to the 6th, and that is 1 mega, and we're measuring watts. Alright, my next one here, I don't, okay, I want to go ahead and add these, so I got 150 times 10 to the third plus 30 times 10 to the third plus 45 times 10 to the third. You'll notice that I'm not using parentheses around these numbers. It possibly makes it a little bit easier to read, but then the numbers run off the screen of your calculator. So I hit equals, I hit engineering, and it's going to be 225 kilowatts. All right, my next one there is technically not an engineering, or technically the engineering would be times 10 to the 0, but the math is the same if you do 500 plus 300 plus 500 versus if you do 500 times 10 to the 0 plus 300 times 10 to the 0 plus 500 times 10 to the 0. As long as you understand that 500 and 500 times 10 to the 0, there's no difference. Any number times 10 to the 0 is just that number. So I'm not going to do the engineering notation on these. I'm just going to keep them in decimal. 500 plus 300 plus 500. You hit equals. You hit engineering, and it converts it for you. Now all you got to do is look at this. Of course, you're going to keep the 1.3. That's your numerical value. You look at the times 10 to the third. That tells you your metric prefix, which is kilo. And then finally, we are measuring volts here. So my electrical quantity is volts. 1.3 kilovolts. Notice, not 1300 volts, 1.3 kilovolts. Alright, my next one I have 950k ohms, so I'm going to do 950, middle button bottom row, times 10 to the third, plus I'm going to do 50 times 10 to the third, equals, hit engineering, and again this is going to be 1 mega ohm. It's not 1,000 kilo ohms, no, it's 1 mega ohm. Right, next we look at the multiply, and again we're going to take two numbers in engineering. So for number 46, I've got 6 times 10 to the negative third. So looking at my calculator, I'm going to go 6 times 10 to the negative, hit your negative button, to the third, times 3 times 10 to the third, giving me an answer of 18. If I hit engineering, it's 18 times 10 to the 0. I'm measuring volts. There is no metric prefix for this because it's times 10 to the 0. So my final answer is just 18 volts. Now notice here it's asking for metric prefix. My numerical value being the 18. Metric prefix, well there isn't one this time, an electrical quantity of volts. But since it's asking for metric prefix, there isn't one. So it's just 18 volts. Alright, my next one here, number 47, I'm going to have 2.2 times 10 to the 0 times 6.5 times 10 to the 0. And that's going to give me an answer of 14.3 ohms. There is no metric prefix this time. Number 48, I'm going to do 5 times 10 to the negative third times, all I'm doing different here from my addition above in numbers 41 through 45, I entered a plus sign in between my two engineering notation numbers. In this case, I'm entering a multiplication sign in between my two engineering notation numbers. So number 48, I have 5 times 10 to the negative third times 2 times 10 to the sixth. I hit equals. I hit engineering, and it tells me that it's 10k ohm, 10k ohms. We're going to do some dividing. So we got 750 times 10 to the negative 6. So on my calculator, 750, little button bottom row, times 10 to the negative 6th. So that'd be 750 micro. And when it comes to dividing, you can hit the divide symbol right here. But I prefer to hit the over-under button. Looking at our calculator, I prefer to hit this button right here, because this is a natural display calculator, and if we hit our over-under button, it allows us to enter numbers into our calculator exactly as they would appear on paper in formulas such as Ohm's law that we'll be dealing with later. Trust me, it's better to use over-under, because when we get into using Ohm's law, this is exactly how it will appear on paper, and it'll be more clear to you. So 750 times 10 to the negative 6 divided by 3 times 10 to the negative 6 equals 250. If I hit engineering, it's 250 times 10 to the 0. Well, that's just 250. And I was measuring volts. So it's 250 volts. Alright, my last one is going to be 55 times 10 to the 6th over under 11 times 10 to the 6th. And that gives me 5. If I hit engineering, it's 5 times 10 to the 0, which is just 5, and we're measuring amps. Now, for those of you that are enrolled in my class, there is a corresponding assignment on Canvas, and you will take these numbers that you've worked out on paper here, and you will type them in to that Canvas assignment. Thank you. I hope this has helped you out.